The concept of precision de-icing is using an algorithm to eliminate any excess salt brine when applying it to the road. This is a more eco-friendly approach and reduces salt brine expenses. The algorithm applies many different variables such as the rotation and the revolution of the Earth. This allows us to create a map that shows roads and their vulnerability status. The vulnerability statuses range from less vulnerable to most vulnerable. This here is a map of Knoxville, Tennessee, and is applied with the algorithm that sets each vulnerability status. As you can see, roads are colored by their vulnerability status. Purple is the least vulnerable, green is less vulnerable, blue is more vulnerable, and red is the most vulnerable. In the future, this intellectual property will be able to be purchased. This is a prototype of the precision deicer that knows based on GPS location and the algorithm how much salt brine to lay on the road. The deicer uses 3 different solenoid valves set at different percentages to accommodate the different vulnerability status. This is the first solenoid valve. It is set at 25% and is turned on when the system detects least vulnerability status. The second solenoid valve is set at 50% and is turned on when the system detects less vulnerability status. The third solenoid valve is set at 75% and is turned on when the system detects more vulnerability status. The system turns on the 25 and 75% valves when it detects most vulnerability status. This is the deicer going through all the settings. The solenoid valves allow the machine to switch the valves in seconds. This is the prototype being tested at a local high school parking lot. The Raspberry Pi in the prototype takes the GPS location and then applies the data from the algorithm to match the vulnerability status. The prototype has a 200-gallon tank that can carry salt brine. Because it uses less salt, the deicer's durability will be increased. There is an LCD screen in the cab that shows the driver how much salt is being distributed and the location of the deicer. The prototype will also keep track of how much brine is used overall for historical data. The prototype's distribution width is that of 1 lane on a road. This is imagery view of Dogwood Road that we use for the prototype demonstration. The road has a vulnerability status of less, more, and most. This is Dogwood Road. This area is red for the most vulnerable status. As you can see, there's a lot of foliage around that produces shade. In this area, we'll be laying down 100% salt brine. This area of Dogwood Road is less vulnerable. As you can see, there isn't a lot of foliage and the road is straight. This part of the road uses 50% of the salt brine. The last part of Dogwood Road is more vulnerable. It has a little more foliage and curves a little. The prototype will distribute 75% of the brine on the road. This here is the prototype going down Dogwood Road. Here it is dispensing 100% of the salt brine. And now here it is dispensing 50% of the salt brine. And finally here it is now dispensing 75% of the salt brine. Feel free to contact us at our website or at our email.